Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will calculate the equation of a tangent to a curve. So let's do this question here. What is the equation of a tangent to y equals x squared at the point x equals 3? So let's quickly draw y equals x squared, just a rough sketch so it looks something like this. So of course this goes through the point x equals 3, y equals 9. So the tangent to the curve at this point is a line that passes through this point but doesn't hit the curve at any other point in that region. So this is the tangent to the curve, and sorry that it's poorly drawn. So I am essentially finding the equation of this line here. See, I can find the gradient of this line here very easily. It's just the derivative of this function evaluated at 3. So the derivative is 2x, and if x equals 3, the gradient is just 2 times 3, which is equal to 6. This line here has gradient 6 and passes through the point 39. So the equation of any line can be written as y equals mx plus b. All you need to do is find m, which we do from the gradient, dy dx, that gives us the gradient, and then we find b. So the way that we find b is by substituting m from the gradient, x and y from the point it goes through, into this equation, y equals mx plus b. So for our example here, we have y equals 9, m equals 6, and x equals 3. So we have 9 equals 6 times 3 plus b. 9 equals 18 plus b. Subtract 18 from both sides. You get b is minus 9. The equation of this tangent here is y equals mx plus b. So just so we're aware, each point along this curve has a different tangent, and the tangent would have a different equation. So let's look at another example. So we're going to calculate the equation of the tangent to this curve at the point where x equals minus 1. See, unlike in the previous example, I'm not going to graph this. I graphed y equals x squared in the previous example just to show you what's going on. I don't want to graph this because it would take forever. Thing is, I don't need to graph it. See, the equation of the tangent at any point is y equals mx plus b. So all I need to do is find m, substitute it, and then substitute x and y, which comes from the point. So if x equals minus 1, to find the y value, I just substitute in minus 1 into this equation up here. So remember, when you're substituting a negative, you need to use brackets. So substituting x equals minus 1 into here, I actually get y equals minus 2. So this curve goes through the point minus 1, minus 2. Now I need to find m. The way I find m, which is the gradient, is differentiating this and substituting the x value. So the derivative is 12x cubed, differentiating term by term, plus 3x squared minus 10x. So if x equals minus 1, then the derivative, all I do is substitute minus 1 into this equation here. So I actually get here y dash equals 1. What that means is, at the point x equals minus 1, the gradient of this curve is 1. So now I have all I need to substitute into this equation. I substitute the gradient m, which is the value of y dash, substitute x and y from the point. So I get y equals gradient times x plus the y-intercept. So then I'm going to add 1 to both sides to get minus 1 equals b. So the equation of the tangent to this curve at x equals 1 is just y equals gradient times x plus y-intercept. How easy is that? All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.